Thank you for joining us. My name is Lucas. I am an engineer and I'm the education director at Fidgets. So a lot of you may have previously met me at conferences, events, or even just online. Today, the plan is to talk about advanced sensors with Java. So again, I've probably said this a bunch of times now, but if you do want to follow along, here's the link and here's the schedule for today. So what we're going to start with is what are Fidgets? So I just want to do a really brief overview of what Fidgets are, just in case someone here in this meeting hasn't used Fidgets yet, or maybe they haven't received their Getting Started kit yet. So I'm just going to take a few minutes on that and just get everyone up to date. I want to make sure that everyone has their kit and their sensor. So for participating in today's webinar, you guys will all be receiving either a light sensor, which looks like this, or you'll be receiving a sonar sensor, which looks like this. So I just want to talk about that quickly and make sure everyone has this kit and they have their sensor. And then after that, I just want to do a really quick review on how to actually use the Getting Started kit. So this will just be a few minutes. I've had some teachers kind of try to create their own lesson plans for this and their own assessment. So this will just be a way to make sure everyone knows that, hey, there is actually an online course and there's assessment and everything. And I'll also let you guys know about the resources that are available for that kit. And then we will move on to using the Sonar and Light Fidget. So again, the purpose of today's webinar is that kind of everyone is now, or should be now, kind of familiar with this kit. And now we're saying, okay, well, what's next? What's the next step? So we'll be reviewing the sonar sensor and the light sensor. And I'll just show you guys how I would code it, how I would code against it, how I would create my programming environment, like configure my programming environment, just some tips and tricks that might be helpful for when you guys are doing this in the classroom. And then finally, we'll end with this Halloween project. So as you may have noticed, I have this pumpkin right here. So I just wanted to show you guys a little project that we added to the website last week and just kind of ended on a little fun note. We'll do some coding together. So I'll ask you guys for suggestions in my code, and we'll just see how we can take a really basic sonar sensor and a few LEDs and make it into a kind of interesting project. So to start, let's talk about what Fidgets are. So I have a slide here just to kind of help me keep on track. So if you guys are totally new to Fidgets, what they look like, as I just kind of showed you guys, is this. So they all kind of fit in the palm of your hand. They're small devices. This is a light sensor. They do usually one thing. So this is a light sensor. It measures the amount of light in a room. This is a distance sensor. It measures how far away something is. So we have hundreds of these types of sensors that look very much like this, and they all generally do a single thing. Some of them do multiple, but most of them do a single thing. I want to point out that there are all of these sensors, that's what Fidgets really are these sophisticated kind of sensors. They're not just this kit. So a lot of people may have received this kit and kind of thought, okay, well, this is like, you know, what a Fidget is. But in reality, this is just one application of Fidgets. So we've kind of added these LEDs, we've added the buttons, but that's just like an example of a project you would do with Fidgets. In reality, people are creating really sophisticated systems with all these individual sensors. So that's what Fidgets are, and I wanted to get that across. How you actually create a Fidget system is you take a sensor. So for example, I take the light sensor. I would take a Fidgets cable. So this is what a cable looks like. And all I'm doing is I'm plugging in to the Fidget like that. And then I take this end, the other end of the cable, and I take a VinTub Fidget. So everyone, potentially all of you have seen this in your Getting Started kit. So it's a 6-port hub. And then what I would do with the other end of the light sensor is I would plug that into any port. And then what I would do is plug the VinTub into my computer. So I would just take a standard USB cable, I would plug it in like this, and then I would plug in this end to my computer. And then I would program against it in Python, Java, C#, Swift, any mainstream programming language. So basically I have a sensor, I have a VinTub, and then I'm connecting that to my computer and I'm programming against it. This VinTub has 6 different ports. So you can plug in 6 different sensors. If you need more sensors in your project, you could just plug in more VinTubs. So we have professional users that have, you know, hundreds of different sensors in a single application, and that would just be them plugging in multiple VinTubs and using them. So that is what a fidget looks like, and that's how you use fidgets. So the really cool thing about fidgets that a lot of you may know is that the same tools that we're giving to students are used by professionals, and they have been used by professionals for the last 20 years. So what we're trying to do right now in education is we're trying to do a really good job of showcasing this. So what we have here, I have some examples here for you guys. This first one is a YouTube video that we made a few months ago. And this shows a professor from the University of Cambridge in the UK and how he uses fidgets. So he's using some of our sensors to monitor these large trees in the rainforest and see how much they bend basically based on the wind. And then I have some other examples here in this slideshow or this slide. And what we're doing right now is every month we're releasing a newsletter on the 15th. So there's going to be one coming out tomorrow. And in every newsletter, we'll be releasing a new video of a company that uses fidgets so that you can show your students like, hey, this thing that you're using, like, you know, you're using this thing that maybe looks kind of fun and like it doesn't look super serious, but in reality, the sensors behind that are actually used in some pretty serious applications. So what you're learning right now is actually quite useful. So yeah, that is just a very kind of basic overview of what fidgets are, just in case anyone wanted a refresher or hasn't seen that before. Using the Getting Started kit, I'm just going to do a really brief overview of how you would actually use this. Some of you may not have actually used this yet. I know some of you have tried it just out today. So what I'm going to do is just show you how to get started. If you look at your kit, you'll notice that on the side here, there's a URL that says fidgets.com/start. So that is the link that you're going to want to go to. So I'm going to go up here and just type that in. Oops. Okay. So I'm going to go fidgets.com/start. And that's going to bring you to this tutorial page. So this is where you want to be when you're first starting out with this kit. So basically, we have the introduction here. We have a little video here that might be interesting. It actually has some other examples of professionals using fidgets. So that might be interesting to you and your students. And then after that, we basically just start with a setup. So this kit comes with the buttons and the LEDs in bags inside the kit. So it just shows you how to set that up, how to actually build the kit, and then how to configure it. Basically, yeah, the configure step just shows you how to like actually set this up. So if you're using Java with Eclipse, that will just give you the instructions and show you how to actually do that. Okay, so after that, basically in the Getting Started kit, what you're doing is I'll just go in this one quickly, just so people can take a look. So for the first one, the idea is that you're blinking the LED. So this is the first kind of project. So if I click through here, you'll get some code, you'll get an example of what it should look like, and then you'll get some assessment at the end. So if we go back here, basically the idea is you're learning how to use the LEDs, you're learning how to use the buttons, you're learning how to use the temperature and humidity sensor, and there's also assessment built into that. So if anyone did not know that, or they were trying to create their own curriculum for this, please check that out. And then one more thing is, if you haven't got started with that yet, one thing I want to point out is in the news tab here. So if I go to the very top, there's this news tab. If you scroll down, you can actually see past events, so past webinars. And then you can actually find the latest, like if you're getting started with the Getting Started kit, I would recommend checking out one of those and just following through with it. So it would have either been me or Ellen doing it, and it's just a nice way to review it. That's a really good resource if you're just trying to get some information about a certain project. So we will talk now about how to actually use the sonar sensor and the light sensor. Okay, so at this point, what I'm going to do is just go to our home page for education. So this is the home page for the education site. So fidgets.com/education. So this is actually, you can also get to the Getting Started kit from here. If you click on the Learn tab and then you go to Getting Started, this will bring you to that same page. So that's another way that you can access that. So the idea now is that, okay, my students have completed the Getting Started kit. They've done all the examples. So like, what's the next step? This is where you would go to level 2. So as you can see, we've leveled them, level 1, level 2, level 3. So we're going to jump into level 2, which is device tutorials. And then what I'm going to do is I'm going to start with the light sensor. So if you opted for the light sensor, this is what you would do. So you'd go to the device tutorials page, And what we've done here is we've picked 8 sensors that we think work really well for education. So they're a good step up from the Getting Started kit, but they're not kind of too sophisticated or too advanced. So we've taken 8 out of the 100 or 200 sensors that we have, and we've created assessment and tutorials for them. So I'm going to find the light sensor, so I can see it in this list right here, the LUX 1000. So it just looks like it does here. So students can just look at their device, look at the page, and try to find the one they have. Okay, so if I click through here, if you've gone through the Getting Started kit, this will look very similar. It's a very similar format. So we have the image of the device here, and then we have a description. So basically, this light fidget measures brightness in lux, and it tells you how much light there is per square meter. So that's the basic description of this light sensor. So for the setup, this is what you want your kind of desk to look like. So I'm going to do that right now. So again, I have the Vint hub. So I have Vint hub, light sensor, and then USB cable. So I'm going to plug this into my computer. And then I'm going to scroll down. So here's the code section. So we always provide base code for students so that they have some idea of what the thing should look like. Just like in the Getting Started kit, I can click on this set my language and IDE link here. And then from this section, I can configure my preferences for the website. So today I'm on a Windows machine. I'm using Java, and I'll be using NetBeans. So I'm going to press done with that. And then that will make sure I have the right code right here. So what I'm going to do is I'm going to open up NetBeans and just give you guys just going to delete this project. Where's delete? Okay, so I'm going to give you guys just an overview of how I would actually set up my Java project. So Java is slightly, there's slightly more to it than something like Python, but we've still made it pretty easy to get started. So all these instructions would be in the configure section of the Getting Started kit. So when you first use this, there'll be a guide on how to actually set up your environment, but I'll just quickly go through it here. So I'm going to call this one light because we're using the light sensor. And then I'm going to press finish. It's going to create a new NetBeans project for me. In the Getting Started kit, you will have downloaded a folder for Java that has some files that you need. So all you do is you just reference them. So I'm going to add a jar, which I downloaded earlier. So it's in my downloads. You download this zip file and then you extract it and you have this. So if I go in there, oops, I'll find this jar file. So that's the file that I need to use with Java. So I'll open that and it will link it right here. And then the last thing I have to do is open up my project files. And then what I'm going to do is I'm going to drag in the x64 folder these DLLs. So I'm dragging this into my project, and then that allows my project to be, that means my project's configured now. So again, the steps to do this are in the Getting Started kit tutorial page under the configure section, but there is no installation required, so you don't need your text unless you're on for Windows, you don't need your text. For Mac, you do right now, but if you're on a Windows computer, all you need to do is just download that file and kind of drag some things in. And we're working towards that on Mac as well. I'm going to go back to the light sensor page. I'm going to scroll down. So again, we have this set up now. I have the light sensor connected. And then what I'm going to do is I'm going to go down here and copy this code. So you can either highlight it and copy to your clipboard, or you can use this button up here and just press copy. And then I'm going to go into this file. And what I'm going to do first is, there we go. I'll make this a little bit bigger. So what I'm going to do is I'm going to say Control A and Control V. So that will paste the code from the example into my editor here. And then what I will do is I will press run just to see if we can get some output here. So I pressed run. This is our output. I'm just going to drag the output down here. Okay. So basically, this is the output from the device. So this again is in units of lux. So if I were to cover it with my hand, we'll see the values drop down near to 0. And again, if I let it kind of see the room, it's reading about 500 or 600 lux. So you could use this sensor if you actually wanted to log like specific data about something. Like I want to know how much lux this plant is like, you know, experiencing over a month. That kind of real analysis with units would be useful. If you're just using this for a, you know, is the light on or off, you could imagine that just putting a simple if statement saying like, if the illuminance is less than, you know, 50, then I know it's gotten dark in the room and I can do something else. So there's kind of two applications. You could either use it in the simple way, or actually the units might actually matter to you. So that's what the output looks like. And I'm just going to go through the code now, just so that everyone has an idea of what's actually happening. So, okay. So the first step here is we're importing the Fidget libraries. So what this is doing is it's actually importing this jar file into your program. So it's saying, I want to use basically every class that's in that jar file. So if I were to go dot like this, you can actually see all the different classes. So if you wanted to if you're just using the light sensor and you want to use just the light, you could go find the light sensor and just import that. But by doing the asterisk, we're importing everything. So we're saying, hey, we're going to use everything just in case. So every single Java program will have that. This line up here is actually just for NetBeans projects. I'm not a super Java person, but like NetBeans requires that for some reason. Eclipse doesn't, but if you're using Eclipse on the website, this line won't be included in your code, so you don't have to worry about it. So this is the first kind of line for Fidgets. The next line is the creating the light sensor. So again, there's many different classes with Fidgets, so there's many different devices. So for the light sensor, if I unplug it here, in the bottom left corner, you might not be able to see it here, but when you get it, you'll be able to. There's always a little indicator of what object you're using. So on the device itself, it'll say that it's a light sensor. So that's one way that you can know that, hey, this thing's a light sensor. The other way is just by going on, like for education, we'll always have code samples. So if you have a device, you'll always have a piece of code to rely on. But basically, this thing is saying, hey, I want to create a new light sensor and I'm calling it light sensor. So this part here on the left side, obviously, just like any other variable, it could be called X, it could be called Y, it doesn't really matter, but we just call it light sensor for readability. So this is the real part here that's actually referencing a Fidgets class. So the next step is opening it. I asked this last week, well, I guess I'll ask it again. So does anyone have an idea of what the 1000 does? Or any questions about the 1000? And it looks like Ellen's answering some questions in the chat. So Angela says calibration, or maybe she's talking about the chat, maybe not this. Yeah, exactly. So Jeff's saying it lets you, it gives you a second to try to open the sensor. So this is exactly right. So basically what it's saying is, what we've done now at this point in the program, we've created this light sensor object in software, and we have this physical light sensor plugged into our desk. So what we want to do is try to connect the two and like make a connection basically. So that's what the open call does. And what the 1000 does is it says, hey, if you haven't found a light sensor within 1 second, I'm going to throw an error just to let you know that, hey, there's probably not a light sensor. So the reason that exists is because a lot of people will have really complex systems, professional users, so they might have, like I said, hundreds of sensors. They might be doing stuff over the network. So sometimes you'll need to increase that. But for students, you can always just leave that as 1000, and that should be fine because they're usually just working with a small number of sensors. So I'll show you guys an example of what that actually means. So what I'm going to do is I'm going to change this to 3, and then I'm going to unplug my, so I have no Fidgets plugged into my machine right now. So if I run this, I should get an error after 3 seconds. So like 1, 2, 3, I should get an error here saying timed out, no Fidgets were detected at all. So if I would have set this to, 40 seconds, it would have taken 40 seconds before it said, okay, I tried looking for this Fidget for 40 seconds. I couldn't find it, so I'm going to give you an error. So again, for education, if we leave that at 1000, that should be sufficient for virtually every single project. So So not much to worry about. And again, the units here are milliseconds. So 1,000 milliseconds is 1 second. Okay, so after we've opened the device, so basically if it gets past this line of code, that means that it has found the light sensor and it is ready to use it. If it doesn't get past that line of code, it will error. So it's pretty easy to see if it finds the light sensor or not. So the next step after that is we're just creating a while loop. So we say while true, so we're just continually polling this thing, and we're saying light sensor dot get illuminance. So this is a piece of code that's saying, talking to light sensor and basically saying, can you let me know, can you give me your latest light reading? And we're printing that out to the console. So we have it wrapped in this string here. But if you just got rid of this, actually, I'm not sure if this will actually work in Java. Let's see. So if I get rid of that and I run this again, it should, so now it's just printing out the illuminance values without the string attached to it, without the kind of like wrapper string. So that is it. And then what we're doing here is we're just sleeping. So we use sleeps in while loops just to kind of like slow down the gathering of data from the sensor. In reality, if you didn't have a sleep there, your computer would be going through that while statement as fast as possible, which is potentially like millions or billions of times a second. So the light sensor is not updating that quickly, so there's really no point in doing that. So we say 150 milliseconds, so we're getting a nice kind of stream of data. If you wanted to export that to a CSV, or if you wanted to like, graph it or something, that's kind of like a nice rate. One thing I wanted to mention too, I'm just gonna go back here just to show you guys. In the Getting Started Kit tutorial, we recently added this advanced lessons button. So in this advanced lessons button, there is a section here on data interval. So that'll actually show students how to change the data rate from the sensor in a different way. So I just wanted to mention that there is an advanced section now. I forgot to mention that. Okay, so that is the kind of basic Fidgets program. And as you can see, that was 1, 2, really 3 lines of code to get this sensor, this high quality data out of the Fidget. So that's really the kind of the benefit of Fidgets is that, you're plugging something in, you're, 1 plug, 2 plugs, maybe 3 things to plug in, and then you write 3 lines of code, and then you have access to this data. So that's why it's really, really nice for any kind of coding class or any kind of class where you want to focus on a project instead of like if you want to say you want to focus on a project with a light sensor instead of building a light sensor, that's where Fidgets really shines, is because you don't have to worry about every student spending 3 classes trying to build this on a breadboard. You're just plugging it in and then you're focusing on your software. And that's actually why the professional guys like it too, because a lot of times you just kind of want to do a project. You don't want to worry about creating a specific sensor. So if anyone has questions on that, so the question here is, do you always have to have your laptop connected? You always have to have some type of computer. So we have wireless modules. This thing right here, if you have the Rover kit or if you've seen the Rover kit, this is a wireless version of the WinTub. So you could have this sitting in the corner doing something. What you could also have is you could have a Raspberry Pi. If you guys have Raspberry Pis in your classroom, that would be an idea if you wanted this thing to just kind of sit in the corner and run autonomously, like without any kind of input. That's how people actually do that in the real world, I guess you would say, is they would connect their Fidgets to a Raspberry Pi and then it would do its thing. So if you want to create like a robot or something like that, so that's a possibility. I'm going to go back to the light sensor page. So basically, students will have now copied this into their project. They'll have ran the program. And what we have down here, if they keep going, is we have an applications tab and we have a practice tab. So in the applications, it just gives them some idea of like, this light sensor, where you may have seen it. So, one application we give is on a phone. If it, detects that it's kind of low light, it'll maybe lower the brightness of the screen because you don't need it to be as bright. And that's using the exact same technology as this. It might even be the same chip. So it just gives them some idea of where they would actually see this in the real world. And then again, for you guys, we have a practice section built in. So if you do have light sensors in your class, this would be a good way to say, hey, okay, you've done the Getting Started kit, but now do the light sensor tutorial so that you have an idea of how to actually use this device before then transitioning to a larger project. So we highly recommend doing these device pages because they just allow the student to work with an individual device before they, because usually what happens is they'll want to do a bigger project. So they'll kind of try to do everything at once. But in this situation, it just allows them like a nice way to transition into that bigger project. And it also allows you guys to have some kind of maybe way to assess them. So, have you completed, all 4 practice problems on the light sensor page? So that is the light sensor. So now I'm going to transition into the sonar sensor. So Rob says in the chat, just to take a quick break from this, what application with the with the Raspberry Pi? We're actually going to do a webinar next week. That is the Raspberry Pi with Fidgets, but there's like a ton of different applications. One of them that we have in the office is we have a light sensor, a temperature/humidity sensor, a sound sensor, basically an environmental monitoring system. So it kind of sits in the corner with the Raspberry Pi, and it logs all this data, and then it makes it available on a website. So that would be a cool I think that's actually what we're going to do in the webinar over the next 2 weeks, is do like a Raspberry Pi project where we kind of create this thing that sits in the corner, logs data, potentially does like a website. So, but there's so many different applications with the Raspberry Pi. It's super varied. Sonar sensor is right here. So again, we look at the sonar sensor, we find it on this page, we click through. Okay, so we get the exact same setup here. So we have the image, we have the description. So for this sensor, it's using ultrasonic pulses to measure distance. So basically it knows the speed of sound, and it can use it to figure out how far away things are. And its default measurement units are millimeters. So what we'll do is we'll go down here. We'll do the exact same thing that we just did. So one thing I want to show you guys is when you're unplugging these devices, there is a tab on the cable. So you really want to make sure students are pushing down on the tab and kind of applying a downward force. That's like the easiest way for it to release. Sometimes students won't recognize that there's actually a tab on the cable, and they'll just try to pull it out. So always nice to just make sure that, tell them that, hey, there's a tab, kind of put a downward force on it, and that's the easiest way for it to kind of come out. I have now the setup that is shown in the picture. So I have the VIN tub and the sonar, and then I'm going to scroll down. So again, we get this piece of code here. So I'm going to copy it with the copy button in the top right, and I'm going to paste it in here. So I'm going to get an error here. I'll show you guys why. So I'm getting an error here just because the name has changed. It's expecting the name to be light because I've named my file light. So I'm just going to quickly change that here. The instructions on the page will tell them to create a new file called Sonar. So, but if they don't create a new file, all they have to do is really change the name if they don't want to go through that process again. So if I run this program now, we can see a output here. So I'll just make that bigger. Hopefully everyone can see that. There, I'll make that bigger. So what we're getting here is a reading of 2000 millimeters, which is 2000 meters because it's pointing at the ceiling. So it's approximately 2000 meters away. If I put my hand in front of it, you'll see the reading go down. And again, this could be used as some kind of an object detection. So, if something kind of walks by it, you'll see that drop, and you could use it to do something else. Or you could use it as a measurement tool. Like some students could do, like I want to measure how tall I am, so I point it at the ground. So you could actually use it in that way too. So it's similar to the light sensor in that way. So to quickly go through the code, exact same setup. So we have the import. So we're always going to have that import no matter what. Instead of creating the light sensor, now we're creating the distance sensor. Again, I could call this sonar. Doesn't really matter. The main thing is that we're actually creating a new object with the class distance sensor. And again, the class name will be on the device itself if students are ever confused. Again, we have the open call. So we've created the distance sensor. Now we want to communicate with the physical one. And then we have the while loop. So again, we're saying the call this time is distance sensor.getDistance, and that's returned in millimeters. So very, very similar to the light sensor, really easy. And this is why it's kind of easy to get a larger project going, because as you can see, like I could now plug in the light sensor, and now I have this 2-sensor system, and the code is not much more complicated. So if I go back to the Sonar Sensor page now, again, we get the applications tab. So just to give students an idea of where they may have seen this in their life. So, you know, this is very similar to technology that's used on cars to detect if there's someone in their blind spot. Assembly line. So this is a really big application of this type of sensor. People will mount these on assembly lines just to know when the next kind of object is coming through. So there's a lot of different applications. Those are a few just for students to get some idea of it. And again, we have the practice. Okay, so this is the distance sensor page, actually the sonar sensor page. And again, I got to that by going learn, and I went to device tutorials. I want to quickly go over the project here. So this is if you guys have fidgets in your classroom right now, and you're looking for a good project for Halloween, this is just a little example of what you could do. So again, if I go to the learn tab here, so I'm going to go back to the main page. If I go to the learn tab, so getting started kit, device tutorials. So again, the next step now is projects. So this is, you have a bunch of sensors and you want to now combine them into a project. This is where students would go. So what we've done for October is we've added a project in here called, so if we go here, we can see even there's some extra getting started kit projects here. But if we scroll down, we'll see this Halloween scare project. So if you guys click through to that, we'll see this. So basically this is showing students how they can take the sonar sensor and the LEDs from their getting started kit and kind of create a more fun project. So again, we're using the sonar sensor, we're using LEDs from the getting started kit. So we used 2 getting started kits so that we could get 2 red LEDs. But if you just have one, you can use, you know, a red and a green LED. And the idea for this project was that we have this kind of pumpkin here. And what we did was we put a red LED, or sorry, 2 red LEDs in the eyes. And then we have a bin tub kind of hidden inside. And then we have the distance sensor. And what we want to do is we want to create this like automated project. So everyone's walked by those houses, you know, during Halloween that have all the crazy automation. So this is one way that, you know, your students could actually do that is with their fidgets. So I'm going to copy this code into my project. So again, I'm going to get that error just because my project's name is light.java. So I'm just going to rename this to light and rename the class to light so that it's happy. And then I'm going to run the program, and then we'll just quickly talk about what's happening. So if I run this, we should see the eyes go off on the, oh, I got to plug it in first. I did that last week too. I didn't plug it in before I press play. Okay, so press play, and we should see the LEDs go off, so we can see that. And I just want to quickly talk about the code and what it looks like. So just like we saw in all the other projects, we have the import. Now this is what it looks like when you're using multiple fidgets in a program, is you basically just create them all in a sequence here. So I have the distance sensor because I'm using a sonar for this project to detect people. I now have digital outputs. So if you guys have done the getting started kit, you'll be familiar with the digital output. So I'm calling it left eye and right eye instead of like red LED and green LED, just to show students that, hey, this is a way to make your kind of code more readable. So hub ports. So this will be something that's familiar with you if you've done the getting started kit. So students will have a good idea of how to do this. They're setting the hub port of where their LEDs are. And then finally, they're just opening everything. So this is all stuff that's been covered up to this point. So it should be easy for students to get started. And then at this point, what we're doing is we are, as we can see here, we're printing out the distance. And then we are setting the state of the eyes to true. So we're turning on the eyes. So one thing I want to go over with you guys quickly was, if I wanted this to only turn on if someone was close by, is there a suggestion for how I would do that? Does anyone have a suggestion? So what I would do in this situation is I would put an if statement. So I would say what I would probably do is I would create a variable called, I would say double distance equals distance sensor dot get distance. So this will give me the latest distance value from the sensor. I can print that out here, and then I can use that to create a conditional that will only turn on the lights if someone's close by. So I'm just going to use 2000 here for like 2 meters, and then I'm going to paste this code inside. Let's just paste that in there like that. My formatting is not going to be great. And then basically, if the distance is not less than 2000, what we'll do is we'll turn the states to false. So if we run our code now, what we should do is, or what we should see is the LEDs are off, and then if someone walks by, you can see them turn on. So off, on, bad angle. And I'll do like this. So off, on, off, on. So this is actually the first step of that project. We're asking students to basically do what I just did there. And then the next step of it is to, you can actually change the brightness of those LEDs. So that was in the advanced section of the Getting Started kit, which we reference here. So it's saying like, maybe the closer they get, you kind of increase this brightness of the LED so it kind of like glows or something like that. There's also a lot of other like really good coding skills you can learn from something like this. So for example, if I run this, you'll notice that like if I kind of am in and out, the eyes will kind of flash not really maybe the way I want them to. So one thing you could do is you could have like a cool down period. So they could add some smarts to this loop saying like, okay, well, if the eyes have gone off in the last, maybe like if it's gone off, then maybe keep them on for 10 seconds before trying to go back and kind of create this like this bad effect of like flickering. So you could do a lot of things like that where I want this program to be a lot smarter and more sophisticated. So that actually took long. I ended up taking longer than I thought I would. So I'm going to stop there, but I would recommend checking out this project. And again, you could do whatever. We got this guy at the dollar store. It was like $1.50. But I'm sure people have decorations in their classrooms. So that might be a fun project if you need something going on. So thank you all for joining.